In networking, it's very important to understand the basics. One of them is how to convert binary to decimal and decimal to binary. And the reason is you'll be using IP addresses. And IP addresses are used in decimal notations, but those decimal notations then will have something called subnet mask. And the calculation of subnet mask or subnetting will depend on your understanding of binary conversion. If you're really good in binary to decimal conversion and vice versa, then it makes it a lot easier to do this subnetting. I'll give you some examples here, how to compare some binary numbers. There is a rule you can use it, multiple rules available, or multiple processes or methods you can use, but this may be quite easy to get on with subnetting quite fast. So I'll show you some numbers here. Let's say you have a binary number which is 110. This is 3 digits, or maybe you can have just 0, or maybe you have 1, or maybe you have 1 1, or maybe you have 1 1 1. These numbers actually, if you count, this is 0, this is 1, this is 3, this is 7. But how do they actually count from binary to decimal? It's quite simple. Let's take this number 111 and convert it to 7, and I would take the 111, then I would cross the first one, write it down here, then I would use the formula to multiply by 2, and then I will count. This needs an index or a power. I will count except the number that I crossed. I would check how many digits are left. You could see 1 and 2 here. So then the 2 will have a power 2 here. Then I will close that bracket. Then there's a formula to add the numbers together, and I will then cross the second number. If it's 1 or if it's 0, whatever it is, write it down. As soon as you cross it, write it down. Then multiply it by 2. Then you check now how many digits are left. You see just 1 is left. That means a power of 1. Then close that bracket. Then plus, open another bracket, use the other digits, which is 1, write it down straight on, then multiply by 2. And then how many digits are left? Nothing. That means power of 0. And then we do the bit mask or bot mask, however you call it. Bit mask is the formula. You do the bit mask, brackets, index, division, multiplication, addition, and subtraction. This is the order you do the calculation one after another. So because we start with brackets, you see whatever is in the bracket has to be done first. We've got 3 brackets here, and if I start what's in the bracket, I see in the bracket I've got multiplication and an index. Before the multiplication we have index, so index first. So I would still keep the 1 times, but this 2 means 2 times 2, and that gives you 4. And so 2 times 2 now is 4, plus we do the 1 here as it is, and then we add 2 to the power of 1 is just 2, and then plus, and then 1 here, and 2 to the power of 0 is 1. Any number to the power of 0 is 1. So we now do the second part, again brackets, and inside the brackets, the first one, we have no division, but we have multiplication, no index, we have multiplication. So 1 times 4 becomes 4, then plus, and then 1 times 2, it's 2, and then 1 times 1, it's 1. If you now combine 4 plus 2, 6 plus 1, that's 7. Okay, I want to now change. So you've seen the beginning was 7, 1, 1, 1 equal to 7. If I want to put them back to binary, I would just take the 7 here and then divide by 2. If I divide by 2, then this doesn't divide into equal parts. We will have 3 and 3, and then a remainder of 1. So I'll put the 3 here, but the remainder I'll just put it there. Then if I divide 3 by 2, it will be 1 and 1, then there will be 1 remainder. So the division is 1, but you have a remainder of 1. Can you divide 1 by 2? No. So we take it over, we take it as a remainder. Now if you count it from bottom top, you will have 1 1 1. So it goes back to where it started. And if I give you another example, the first one, this is 6, but let's see how it works. If we have 1 1 and 0, we cross the first one, and then we open a bracket, write that number, and then times 2. Then you check how many digits are left. It's 2 digits, so you put it as a bracket, as an index. Then you add, open another bracket. What number is in here? That's 1. Cross it, and then write it down here, times 2. And then you count how many digits are left, just 1. You use it as a power, and then bracket, what number is in there. A lot of people get confused when they are writing ones and zeros. As soon as you cross whatever that number is, write it down. Otherwise, you might write 1 instead of 0. So time is, then the formula says times 2. How many digits are left? Nothing. So we put as an index of 0. Now we use the formula bitmask. Brackets first. So whatever is in the bracket, and inside the bracket we see again there is index, and we work with the index before the multiplication. So we keep 1 as it is. 2 to the power of 2 is equal to 4, and then we put 1 here. 2 to the power of 1 is 2. Then we put 0 as it is. You know 0 multiplied by anything is 0, but before we do that, let's complete and follow all the steps. 2 to the power of 0 is 1. Now multiply 1 by 4, it is 4, plus 1 times 2, it is 2, and then 0 times 1, it's 0, so that number is 6. Okay, so this is another example. And if you want to put this back to binary, again, use that line. 6 divided by 2, it's going to be 3, 3, there's no remainder, so 0. If you divide the 3 by 2, it becomes 1 and 1, but you have a remainder of 1. This 1 doesn't divide by 2, so we take it as a remainder. Now count it from bottom top, and it becomes 1, 1, 0. Goes back to where it started. This is a quite simple way of doing binary to decimal conversion. If now you have numbers like 2 to the power of 0, it becomes 2. But if you multiply another 2 to the power of 0 means 1. But if you multiply 2 by 2, it becomes 4. 2 by 2 by 2, that's 3 times, that's 8. So you are having 2 times 2, 4. That 4 you multiply by 2, it gives you 8, I mean. And then you multiply another 2, that's 4 times, that gives you the 8 you had here, plus, times the 2, that's 16. And then multiply again by 2, that's 32. Multiply again by 2, that's 64. Multiply by 2 again, that's 128. Why are we doing this? Imagine you have 1, 2, 3, 4, 5, 6, 7, 8. Why we 8? Because in IP addressing, we divided it into octets. So octet 1, octet 2, octet 3, octet 4. And each octet contains 8 bits. Those bits can be 1s or 0s. So the maximum an octet or a byte can go is 8 bits. But now, if we are using this formula, when you cross the first one, and you would write it in a bracket, 1 times 2 to the power of what? You would count the remaining digits. So we have 1, 2, 3, 4, 5, 6, 7. Now look at here. 1, 2, 3, 4, 5, 6, 7. If I now use this formula, 2 times 2, it gives me 4. And 2 times 2 times 2, that gives me 8. And then if you multiply by another 2, 2 by 2 by 2 by 2, that's 16. And if you multiply by another 8, that gives you 32. And then if you multiply by another 32, by 2, this gives you 64. And then the last one, if you multiply by another 2, this gives you 128. Then you would see, actually, these numbers can be arranged in this way. 128, 64, 32, 16, 8, 4, 2, 1. If I give you now a number of 1, 2, 3, and then 5 zeros, for example, so 6 here, and then 5 zeros, I'll just put underneath here, say put 1, 1, 1, and then I would put after this, under the 16, a 0, 0 under 8, 0 under 4, 0 under 2, 0 under 1. Then if you use the multiplication here, 128 times 1, it's 128, plus 64 times 1, 64, 32 plus 1, 32, and the rest 0 times something is 0, so we have 5 zeros here. Okay, if you combine them all, then you will have 224. Okay, so this is the short form, but just to give you how to convert binary to decimal and then decimal to binary. And this is 3-digit number and 4-digit number. I'll record another video to show you more examples. Thank you.